Hey you guys, it's me, Miss North. I'm coming to you for week 5 for your instructional video. Today we will be determining the rate of change and initial value for multiple linear equations so that I can interpret the rate of change and initial value. So a lot of what we're doing, y'all, is going to be really just focusing on interpret. I'm going to include some little links in case we still have misconceptions on how to actually find the rate of change or how to find the initial value. But we are literally going to be focusing on this whole interpret part. So let's get into it. Let's start with our, I don't know if this looks familiar to y'all, but last week when I did the video, we actually determined what the parts of a linear equation actually mean. And I feel like when you know what those parts mean, then you are better at determining or interpreting what those situations are. Remember, if I interpret it, I just need you to make my story for it. What story, what situation can I make with this equation? So again, you know, your y and your x are variables. They change throughout the situation, such as day 1, day 2, day 3, hour 1, 2 hours, 3 hours, 4 hours. And so really, I don't really want you to focus on those because they're going to change throughout the situation. They're just units. However, I do want us to focus on the m, which is a fixed number. It will not change. So I have to be able to find the m. And I have to be able to find the b in that also, which are fixed numbers. They're not going to change throughout the whole situation. That what makes it linear. So let's go ahead and start with our do now. And you're going to need this for another part. But again, can you find the do now? Can you find the m in this situation? And right here, I have a link, and I'm going to also attach it on the bottom in case that we are struggling on still finding the m. So getting into our lesson today, I'm going to actually show you one way that we find the equation to coming back out to doing the undo of it. So if I was given a graph, can I find the equation in this? And so basically, the point on the y-axis, when you're looking for your y-intercept, you're looking for the y-axis, right? So at point 0, which is on the y-axis, 3 is where my line crossed. So that will make that the y-intercept. The y-intercept is literally 3, where it intercepted the y-axis. Then, going from point to point, I want to see, well, how did I get from one point to the other? So if I start at 0, 0, at 0, 3, I want to see how much did I go up and how much did I go over. So basically, I went up from 3 to 4, that's 1, 4 to 5, 2. Then I went halfway between 5 and 6. So that's not going to be a full increase. I went up 2 whole and a half, so 2 and a half. Then I want to see how much did I go over. Now, one mistake that a lot of times we make is that I went over one box, 2 boxes, so it's 2.5 over 2. No, make sure you're checking on the bottom for your unit. Halfway between 0 and 1 is 1/2. So if I would have stopped right here or thought that was just one jump, that's only 1/2. Remember, even with my 2 jumps, I still ended up over 1. So my slope over this was 2.5 over 1, which could be simplified to 2.5. So then, let's take that same graph and create a verbal descriptor. So looking at this verbal descriptor, let's see what I have. Tony's taxis charge $3 to pick up passengers plus $2.50 for each mile. Stopping there, we have to realize, well, what does that actually mean, right? Which one will be my B and then which one will be my M? Write an equation for the function that relates to the total cost of the trip in distance. Remember, total cost is always going to be my Y. It's going to be what I equal. Also identify the slope and the intercepting. So then it says you can use the actual table to help you find the slope. So going over is the same thing. Whenever x is 0, that pair, that other number is your y-intercept. So with this, when x was 0, y was 3. Okay? So my y-intercept is automatically 3. And I can match that back to my verbal descriptor. He charges $3 just to pick you up. So you have to remember, in the real world, before I drive anywhere, I got to hand him $3 off the bat. So that's always going to be my initial value because he's not charging me as we go. To pick me up is $3. And then $2.50 for each mile. I'm now increasing by $2.50, which makes my slope back to 2.5. So here's another clip that we're going to include in the link. But it's how do I create an actual linear function from a graph? So if you need that help, I suggest that everyone go look at it. But it's literally a live model of Miss North creating y equals mx plus b or slope-intercept form equations from a graph. So everyone needs to know how to do that. But let's go back into it. I us to be able to create, so going back into our precept, I want us to be able to create an equation and then therefore turn back into what it looks like in the graph. So using y equals 2x plus 1 to complete the table of values, then use the table of values to create the graph. So again, interpreting the equation through the actual graph, so I'm going to change to my camera. All right, and we're going to still show our whole PowerPoint. And given that I have y equals 2x plus 1, I'm literally going to make that line a little longer. I'm going to show you why. My t-test. So start off with my x's, -2, -1, 0, 2, 1, 2. Then I want to show you exactly what we want to be able to do. So again, I'm going to have 2x plus 1. And then that answer is going to be my y. So again, okay, I got my calculator. So remember, whatever x is, I can replace for this variable here. So in my calculator, I'm going to have 2 times -1 plus 1. So 2 times -2 plus 1, we're going to calculate, and it equals -3. I want to do the same thing. 2 times -1 plus 1, 2 times 0 plus 1, 2 times 1 plus 1, 2 times 2 plus 1. And do that exact same order. 2 times -1 plus 1 gave me -1. 2 times 0 plus 1 gave me 1. 2 times 2 plus 1 gave me 5. I'm sorry, I skipped 1. 2 times 1 plus 1 gave me 3. And then we just saw 2 times 2 plus 1 gave me 5. So then it says to take my graph. So now I have all my x's and all my y's. I'm really just going to put those back together just to make it easier for us to understand. -2 to -3. -1 to -1. 0 to +1. +1 to 3. And +2 to 5. So you see, I now was given, I put all I did was put my x's and my y's together. That's all we need for an ordered pair. And now I'm going to go back to my PowerPoint and let's go back to it. And I'm going to go into the actual draw sequence so that we can see. So again, my first one was -2. I'm sorry, I'm so nervous. Alright. So, my first one was -2, so I started my origin. I go to the left 2 times, down 3. There we go. I'm going to put my first point there. My next point was -1, -1. My next point was 1, 0, and 1. My next point was 1 and 3. And my next point was 2 and 5. So one thing I do want to notice about this graph is that we can take parts of this graph and relate it back to our equation. So if my slope was 2, guess what? 2 equates to 2 over 1. I went up 2 and over 1 for each point. And then my +1 was my B. I can already see that my line crossed over at the +1. So there was just a different way to be able to create your equation. So let's get back into the next slide. So now what I want us to be able to do is I want us to be able, can we create a linear equation without computation? So without trying to create the graph, can we actually do that? So let's look, again, we're going to go right here. And let's focus on this one. Awesome. So basically, I'm looking at my phone bill, and basically, I'm comparing the amount of minutes to the total cost of what my phone bill would be. So I'm going to move that down so we have a little space to work. And I want to see, every time that I create a linear equation from a graph, I know that I'm only looking for the M and the B. So I just list that out just as in my head. These are the only things I need to find. So to find my M, I'm going back to my graph, and I'm going, well, how did I go from this point to this point? Remember, M is rise, which is up or down, over run, which is only to the right. Okay? So let's go up or down. I know that I went up 1 unit, but then look at your units. Even though I only went up 1 square, my squares count by tens. So my squares count by tens. I actually went up 10. Cool? Then I want to see, well, how much did I go over from this point to this point? I went over 2 squares. But again, looking at your units, even though I went over 2 squares, 2 squares from 0 still equals 100. So my run is 100. And I'm going to put that in my calculator just as a fraction. 10 divided by 100. And that equals 0.1. So then I'm going to go back to my B. Remember, your B is literally just where did the line cross the y-axis. Your y-axis is usually the bolded line going down the middle. So, where did it cross? I want to follow my red line all the way to the y. And boom. It crossed at 40, so therefore B is 40. So if I just want to create my linear equation, me personally, I don't want to ever get this mixed up. And it's so easy to get this mixed up, y'all. So I'm gonna always write my template. Y equals mx plus b. And then use those digits, those values that I found for m and b to plug in. So if y equals mx plus b, I'm gonna put y because that's going to stay always a variable. It's always going to keep changing your situation. So it cannot be a constant number. I'm going to put my y equals m, which is 0.1, keep my variable, plus 40. Cool? Let's look at the next one. With the next one, I'm going to move it over. I have a relationship between the time it traveled to the distance from the finish line. So I wanted to use this one, y'all, because it actually saw a negative representation, and I want to be able to just basically expose you to negative numbers and negative representations. So, again, I'm going to do the exact same steps. And sometimes, y'all, we just need these steps. Write my list of my M and my B. Remind myself that M is rise over run. And let's look for M. I went from this point if I'm going to the right, I went from this point, but my next point went down. So if my next point went down, I automatically know that's a negative number, right? So I'm going to go ahead and put my negative there. I'm subtracting. If I'm decreasing, I'm subtracting. I'm getting less of it. Remember that subtraction means I'm getting less of something. So I went from 20 to 15. So I know to get from 20 to 15, I'm really just subtracting 5, right? So that goes on top. Then I want to see, well, how much did I go over? Even though I went over 1 square, yet I am going to keep repeating this. I'm going to keep reiterating it. Even though I went over 1 square, remember, I always go down to the bottom and see, well, what does 1 square represent? In this instance, from that 1 square means from 0 to 20. So each square means 20. So I went over 20. Remember, on your bottom or on your run, or even when you're looking at your X values, you're always going to the right. Okay? So I'm going to have negative 5 divided by 20. And that gave me negative 0.25. Right? And then I'm going to, again, for the B, I'm literally just looking for where did it cross my y-intercept. So again, this is y because 1 is labeled y over here. And then it's the y because it's where my units are and where it's bolded going straight down. So my red line started at 20, so that makes my B 20. So again, I always start with my template, y equals mx plus b, correct? So then I have y equals my m, which was negative 0.25 x plus 20. Easy peasy, right? So going back into our slideshow, let's see if it matches. And if it matches, for the first graph, we have y equals 0.1x plus 40. The second one, we have negative 0.25x plus 20. So then I want you guys to take your time, go ahead and pause the video and just review these words. These are words that are used in word problems. They just help us relate those words back to it. And I want us to be able to pay really attention to words that either mean increasing or decreasing, because those are very big speed bumps that will be thrown at you in any test, especially in 9th grade, to trip you up. Then I want you to take a minute and reflect, what words can you include that mean different operations? Such as, if I'm losing 2 gallons, what operation would that be? If I'm gaining 2 groups at the same time, what operation would that be? Or if I'm getting paid, if I'm paying out. Those are 2 different things. If I'm getting paid, then yes, I'm gaining money. But if I'm paying out, I'm losing money. So I want you to create your own words of how that works out. So then going back into interpreting situations, remember all these elements of an equation mean something. So basically my M means how much the independent variable is changing. Is it increasing or decreasing? You need to know that to be able to interpret equations. Whereas B always means, where did I start off with? Your B will be positive if you started off with more than 0, but it will be negative if I started off with less 0, such as if I owe somebody something. So let's get into actually seeing, well, what do these numbers mean? So the first description that we have, y'all, is the lawnmower has a fuel tank that holds up to 8 gallons of gas. It uses gallons as the rate of 1.25 each hour. Suppose that the gas tank is full. Write an equation to show how much gas will the tank be after each hour the lawnmower runs, and then identify the slope. So again, like we said, we're not going to worry about identifying slope because I want our main focus to stay interpreting what it means. So basically, if I needed to interpret this graph and I found out that the intercept was 8 and the slope was negative 2.5, I can say, well, the lawnmower started at 8 gallons and then I subtract or I lose 1.2 gallons each hour. That is what I mean with interpreting. Literally using the words that you already use every day to tell me what this equation means. So then let's go ahead and do another interpretation problem. This equation shows the amount that a candle is left in ounces after burning for X hours. What is the y-intercept of this function, and then what does it represent? So let's go back. Let's basically dissect this whole equation. So dissecting this whole equation, y'all, I blocked out, or I grayed out the y and the x, because again, it changes. It changes from to situation to situation. But my M and my B can never change from this situation. So let's look at my M. If my M is negative 0.2, how much of the candle how much of the candle I lose every hour? No matter if I burn it 2 hours, 3 hours, 4 hours, 5 hours, I'm literally only losing 0.2 ounces of the candle. Then let's go to the 12. The 12 is how much I start off with this candle. Therefore, if I went and bought this same candle repeatedly from Target, then guess what? That candle better be 12 ounces if I keep choosing to pay this amount of money for this candle. It's always what I start off with. Okay? So that's the situation. So that's going back into what happened. It's actually for the y-intercept. We've already identified the y-intercept as being 12. And let me explain why we identified it from being 12. 12 is the y-intercept because there is no variable attached to it. It is a constant. And that's literally what a constant means. There is no x or y attached to that 12. Because 12 is over here standing alone, it is my y-intercept. Anytime you have a number attached to a variable, that is your unit rate, no matter if it's in the front or the back. So I already know that 12 is the y-intercept. I also know, just going back to it, I started off with 12. It's not going to change. So that's why it makes the constant, because it's not going to change. Every time I buy this candle, it's going to be 12 inches. So then I can already now eliminate C and D, correct? So then let's go back to B, or to A. It says, well, my ounces burn each hour. That word each means that it's changing. We've already established that 12 is not changing. So A is now out. So then that goes back into what all I'm left with is B. B was the ounces of candles before it burned. And I wanted to show you this problem because there are going to be times where the questions are not saying this is your initial value, this is your slope. It's going to give you things such as each and before to let you know that you need to be able to hook those words together. So my last one, I have a large tank of water that holds 600 gallons and it is losing water as the rate is shown. I want you to be able to find this slope and then do it for your representation. That's going to be your essay ticket for today. I hope that this session was super informal, was super informative. I hope we got a whole bunch of information from it. As always, remember that us teachers, we miss you and we love you dearly. From Dr. Westbrook, Miss Cottrell, Miss Brown, Miss Stoney, and myself, Miss North. You guys have a great week.